In this diagram, I want to talk a little bit about OpenLayers. Can't discuss the whole library. Could be here for like days, maybe even a week or so. There's a lot in it. I'm just going to focus on sort of the mapping side, but even the mapping side, we're going to focus on the concept of layers and that. So in the beginning, sort of deal, when you go through the help, you kind of can start to piece together how some of this is connected in that. There is a base OpenLayers object that not everything descends from this, but it's used frequently in that. But what you might notice is I'm using different colors. And so for a very abstract kind of class type concept, I have them in gray in that. And then for a more what we call concrete, that's more of a Microsoft COM term. We have abstract classes versus concrete classes, but there is this thing where you actually have abstract classes, which you typically don't sit there and go new or make directly. You have to go to a concrete class to actually make it. And by making it, it inherits a bunch of properties and methods from the abstract ones. Now, in this case, the all layers, right? There is this concept that a map has many layers, but all layers have this concept of whether are you visible, what's your max, I guess your extent of all your features, and then do you come on at a, I guess, do you have a minimum and maximum zoom level where you turn yourself on and off? So it wouldn't matter what type of layer you are, that applies to all layers. Okay, so if we talk about one of the first concrete things you can run into if you're in a OpenLayers map is you could run into something, right? You go to a map, hey, give me your layers. And then you can all of a sudden bump into the thing that's actually not a layer at all. It's a group, right? So what it means is that if you need to get at a particular layer, say you need to get to a table of a particular layer, say to base a pie chart or something else on, get the data from that layer. You can't get it from the group. You got to dig down one more level, right? So go to its layers property, which is simple array of layers, and then pull out a particular layer that you want to work with. So it's a way of grouping a bunch of layers together and turn them off and on quickly, and that helps you from the front end that way. But you can go to a map and run into something that you think is a layer, but actually no, you got to dig one more level deeper to actually get to a layer that you might need to use, say, to feed data into another type of control in that. So now this concept of group layers exists in other places. You can find them in ArcGIS feature services and even in the 3 era of their JavaScript, but you can't quite make them directly. I think in 4 you can make the groups and that. And so actually to make a group layer using ArcGIS Online is actually can be difficult. You usually have to publish it with the group already made. So these group concepts exist, but again, it's not a layer directly. You can't take this group and get data. You have to say, well, which layer in the group do you want to use? Now, if we back out, we can see some other objects here. And so we start to see, okay, a layer, right? And that. And we see base image layer and vector layer. So we start to see, okay, maybe there's a raster vector split. But one thing I want to talk about for all layers, once you get one, right, not a group, but get a layer out of the group, an important thing is its source. Where is it coming from? And not only that, where it's coming from also means what type of technology is serving up the data. Is it ESRI? Is it ESRI SOAP XML? Maybe they're still alive and kicking. Is it ESRI REST JSON? Is it OGC? Or is it some new type of service? But that source, we'll talk about it soon, right, is what feeds the data to the layer in the map. And like we said, we have this concept of a base and image layer. So we kind of have this raster vector split. Are you a raster layer? Your images, and those images are typically can be displayed by the browser. So usually it's like a PNG, a GIF, or JPEG format. a format that the browser can handle in that. And so we could get to a concrete thing where we make a layer and the type is image layer, and as long as we provide a source where images are coming out of the back end, we're good to go. These are the classic type of service that you can run into would be like map server, in that, and probably even QGIS map server can operate in this format. But basically, an image is created and sent back to you based on the extent that you feed the back end server. You say, look, I'm looking here, make me an image of the map and what it looks like in this location. Typically, one big image gets sent back to you, right, for the little viewport or box that you're looking through in that. Now that server might be using vectors to make your map, but what it passes off to you, typically single image, PNG, JPEG, GIF format, a format that a browser can handle. Now if we go over here, we also have the concept of tiled layers. These would still be raster layers, okay, but they're pre-chopped up into chunks. When we're doing these are the classic, what I call Google, Bing, and Easerai base maps. Pre-rendered images, map caches is a term here on the Easerai side, but there's some sort of grid system that chops it up. A lot of people use the Google Maps quad tree web Mercator grid system to chop the images, but these would be raster. But the idea is that it's not a single image, right? So you're going to be dealing with, you just got to be heads up aware that, okay, a bunch of tiles are coming in, but OpenLayers will handle that for you in that. And so there's this concept of raster, and within raster, one big image, a bunch of tiles. Okay, but of course there are vectors, right? And this is when you're dealing with vector layers, right? I guess it would be your classic, SOAP XML, probably GML if it's Easerai, REST-JSON, and some other servers. You can flip them to say, hey, don't send GML, send GeoJSON instead. So, but when you're dealing with vectors, you're dealing with point lines, polygons kind of concept in that. And of course, there's also chopped up vectors, vector tiles, and that'd be a good example would be map-up vector tiles are a pretty popular format in that. And so, is your data coming as raster vector, and is your data coming as one big chunk or tiled? Is sort of but this is just at the layer concept in the map. Now, all those layers are based on sources. I actually haven't quite in my mind figured out what vector image is in that, so I'm going to leave it for now in that. So we have a source that I wanted to talk about before. Like all of these layers have some backend server, microservice feeding it data. Okay, and so then you got to go over typically before you can have a map, you need layers, and before you can have layers, those layers need to have a source defined. So we'll go over here. The abstract source object doesn't have too much, right? Copyright stuff, attributions, maybe what your projection is. That's pretty important in that, and the state. But again, these sources can be image sources or they can be vector sources. So there's that raster vector split again. And what gets really interesting on the vector side is the format. So we'll go over here. So these are some classic image servers, right? So ArcGIS REST, right? So it's an ArcGIS REST service, but it's serving up images. Image Canvas, not familiar with. Image Map Guide, this Autodesk bought Map Guide, and so this is their internet map server product. You have the OGC image WMS. So this is the backend service, classic OGC web mapping service. So that's WMS. Typically sending out one big image in that. Unless you request it differently, you can request it differently. And there could be a static image server as well. But let's go take a look at some of this. Besides one big image, we can also get it tiled, right? So tiles really help speed up, make your application appear to be faster in that. People see tiles coming in, so they know something's happening. If they're pre-cached, then they are definitely faster in that. And so when we look at these tiled images, here shows up your Bing Maps again, tiled ArcGIS REST services. This means that if you have a tiled ArcGIS REST service, then you've pre-made the images. They're all pre-made and chopped up. But that's how Bing Maps works. It's how Google Maps works. Tile JSON is a way to do tiles, but you're doing the requests for the tiles in JSON format. So it's just adding a layer so that the person writing JSON can actually do the request in a more JSON friendly format. Now, there is this tiled WMS because typically tiled OGC web mapping services are the one below. So what it means is web mapping tile service has the tiles pre-made, chopped up on a grid, right? So these web caches can get, I'm not going to say huge, but they can get big, right? Depending, because if you're going to cache all 28 zoom levels and all the tiles ahead of time, it can take up some disk space, but disk space is cheap and CPU is not, so that's the trade-off, right? We can make this faster by pre-rendering the images. So that's what a WMST does. That's what a tiled ArcGIS REST service does. Tiled JSON just changes how you, more JSON puristic way of getting the data and that sort of thing. And there's all different types of tile services. You can request a tile with XYZ. So where are you? What's your zoom factor? It's another way to, how do you want to chop up tiles in that. XYZ might use that same quad tree breakdown that Bing Maps, Google, and ArcGIS REST services use as well. Now, some of these services allow you to have your own gridded system in that, so just be aware not everyone uses the WebMacator tiling scheme in that. The one interesting one is this tile WMS. So what is the difference between WMS, tile WMS, and WMTS, right? So a WMTS, tile mapping service, is really what we're discussing here is the difference between client side, that being the browser, client side caching of tiles, and the server side pre-cached tiles in that. So with a tile WMS, a single image, it's a single image that gets chopped up into 256 by 256 tiles, then cached by the browser. So this can speed things up on the web interface. So instead of going to a traditional web mapping service, OGC, and saying, hey, one big image, you can say, hey, I'm looking over here. I do need it to be dynamic, but chop it up into 256 pieces, and then, you know, as one's ready, shoot it across, and I'll drop it in. And then and then OpenLayers can start caching them on the browser side. But the idea is that the tiles are not pre-rendered yet, but they can be chopped up into tiles for display and also for caching. So I want to go back to when you're dealing with vector sources, is this format sort of issue. And this is good, I think, but then you get to understand what's going on. So what is the format of the feature? Here we see it could be well-known binary, OGC well-known binary, that when you get a feature out of this layer, it could be well-known binary. Or it could be some type of XML feature, and even there, it could be a GML. GML here is abstract because there's two different versions, which are the concrete versions. But what if it's a GPX file from a Garmin GPS receiver, or keyhole markup language from Google Earth, or some other service that sends the data in that format to you, or OpenStreet XML formats, or maybe it's, you know, the tried, tested, and true OGC web feature service, right? And so those actually come in some type of GML format, but because it's a web feature service, there's a few other things that come with it as well in that slightly change is it name and description? You got to watch those fields if you have those on your tables and that. But what if it's a JSON? And this is why we have abstract classes. Yes, JSON, we know what it is in that. You know, a lot of square brackets, angle brackets, and colons and quotes. But, you know, is that JSON feature GeoJSON, which has a different JSON structure than TopoJSON, which has a different structure than ESRI JSON? And that's why we need concrete versions of this, because yeah, JSON is a concept, but it depends, the devil's in the details. How exactly did you structure that data? So that's all for now.